Hi everyone. In today's lesson from Unit 4.1, we'll learn how to find the area of a regular polygon. First of all, a regular polygon is defined as a polygon that is both equilateral and equiangular. Just a reminder that this means that all of the sides are congruent and that all of the angles are congruent. So some examples of regular polygons that we're familiar with are an equilateral triangle, a square, and then we also have just our regular polygons with more than 3 or 4 sides. In other words, something that we may not be as familiar with would be a regular pentagon. So all 5 sides of this pentagon are congruent to each other, and all 5 of those interior angles are congruent. So regular polygon, all sides are congruent to each other, all angles are congruent to each other. In this lesson, we're going to learn some new vocabulary. In statement 2, it says the apothem of a regular polygon. Apothem is kind of a funny word, but the apothem is the perpendicular distance from the center of the polygon to the side. So we'll fill in those blanks in a second, but let's say we were to draw a square. And if you knew where the center of that square was, if you were to draw in this perpendicular distance from the center to the side, we would refer to that segment as the apothem of the square. So again, it's the perpendicular distance from the center of the polygon to the side. Now, when we talk about the center, we usually think of a circle. Now, if we take and we inscribe or put a square inside the circle, the center of the circle would also be the center of that square. So put that dot where it looks like it's more like the center. So again, this distance from the center to the side would be labeled the apothem. Next, we're going to be taking a look at the radius of a regular polygon. The radius of a regular polygon is the distance from the center of a polygon to a vertex. So if you think back to that previous picture where we had the square inscribed inside of the circle, and this is the center of both the circle and the square, when we go perpendicular to the side, that's the apothem. When we draw the segment going from the center to a vertex, that's the radius. So I just labeled that with R. Another way to look at it, another example, is what if we had a regular hexagon? Now this is a little tricky to draw. So again, a regular hexagon would have 6 equal sides. The center of that hexagon is also the center of that circle. So the perpendicular distance to the side is the apothem, and the distance from the center to a vertex would be the radius. The perimeter of a polygon is just the sum of the lengths of its sides. So it's the distance around an object. So if we had a square, and each of these sides had a length of 10, we'll say 10 centimeters, the perimeter would be equal to 4, which is the number of sides, times the length of each side. So perimeter equals 4 times 10, or 40 centimeters. So another way to think of perimeter is to take the number of sides, n, and multiply it by the length of one side. So again, n equals number of sides, s equals length of one side. Okay, finally, we're going to talk about the formula for finding the area of a regular polygon. It's a pretty simple formula. It says the area is equal to 1/2 AP. area equals 1/2 AP, where A is the length of the apothem and P is the perimeter of the polygon. So sometimes these questions are a little bit challenging because finding the length of the apothem can be tricky and might involve using special right triangles or trig or the Pythagorean theorem, and also finding the perimeter might be a little bit challenging as well. All right, next we're going to take a look at some examples. The first one isn't too hard. It says find the area of a regular hexagon with a side length of 4 centimeters and an apothem of 2 square root of 3 centimeters. Now, first thing you should do anytime you're finding area is just take a second and write down the formula that you're going to use. Since we're told that this is a regular hexagon, we're going to use the formula for the area of a regular polygon. So capital A for area equals 1/2 times A times P. Well, we're lucky in this case in that they give us the apothem. So we're going to take 1/2 and then in parentheses put your apothem of 2 square root of 3. Now, we have to find the perimeter. Remember that they told us in the beginning that this is a regular hexagon. A regular hexagon has 6 sides, and they're all equal to each other because it's regular, and it says the side length of each of those is 4. So we're going to calculate the perimeter, P. I'm just going to do it up here. We'll take the number of sides, 6, times the length of each side, 4. So our perimeter is 24 centimeters. Okay, plug that into our formula in place of P. And then we're going to actually simplify this. Remember that in math, if you're doing multiplication, you can change up the order and it won't affect your answer at all. So instead of writing this as 1/2 times 2 square root of 3 times 24, let's take 1/2 of 24 and then multiply it by 2 square root of 3. You don't have to do this, but just thought it might be helpful. Half of 24 gives us 12, and then we're going to multiply that by 2 square root of 3. We're not going to jump to the calculator because we're looking for an exact answer. It doesn't say to round to the nearest tenth, so we're going to keep this in terms of the square root of 3. 12 times that 2 out in front will give us 24 square root of 3. And then don't forget your units. We need centimeters squared. So final answer is 24 square root of 3 centimeters squared. Okay, in our second example, we actually are finding the area of a regular octagon with a perimeter of 40 inches and an apothem of approximately 6.04 inches. Okay, so we're going to find the area, which is 1/2 times the apothem times the perimeter. So area will be equal to 1/2 times 6.04 times 40. So this one's pretty easy. We're just plugging numbers into the formula and we're going to simplify it. So you can go to your calculator and do 0.5 times 6.04 times 40, and we end up with 120.8 inches squared. Don't forget your units. All right, and our final answer, we're asked to find the perimeter of a regular pentagon with an apothem of 10 centimeters. So we're not even going to use the area formula, although we might take a look at that on the end. We're charged with just finding the perimeter. So it's a regular pentagon. So pentagon has 5 sides. So I'm going to start with a picture of a pentagon. Just make a note that it's 5 sides. And they've told us that the apothem is 10 centimeters. So estimate where the center of your pentagon would be, then drop in a line segment perpendicular to this side. All right, that distance is 10 centimeters. Okay, you might think that you don't have enough information to find the perimeter, but remember that the perimeter is equal to the number of sides times the length of each side. Each of these sides I'm going to label with S. Okay, so perimeter is equal to 5, because we have 5 of them, times S. Okay, so here's where we're going to tie in information that we learned in our previous unit. First of all, if you make little triangles here, if you just draw in 2 radii here, what you have is a little isosceles triangle. These 2 sides are congruent to each other. Okay, I'm going to pull out that isosceles triangle so we can see it a little more up close. This right here is the apothem, and we know that that's 10. Okay. Now, if you were to divide up this pentagon into these 5 big triangles, here's one, that's the second one, third one, fourth one, and fifth one. So we have 1, 2, 3, 4, and then this fifth one. Remember that there are 360 degrees in a circle. So if you take 360 and you divide it by 5, you would end up with 72 degrees. What I just did was I found the measure of this angle in the center, 72. Now, in this triangle, the one that I pulled out over here, if you drop in that apothem, it's going to bisect that angle, making these two equal to each other. So if the whole angle is 72, you divide that by 2, we get 36 and 36. Okay. Now the reason why I'm mentioning this is that we need to use trig to find the length of this whole side. Okay, but we're going to do it in steps. When you drop in this apothem, it's going to bisect this side, making these two equal to each other. So label one of those guys with x. So s, this side in our triangle, will be equal to 2 times whatever we find for x. Okay, here's where the trig comes in. That side marked with the x is opposite to our angle marked with 36, and 10 is adjacent. So we want to work with the tangent function. So I'm going to say that tangent of 36 degrees is equal to x over 10. Treat it as a proportion and cross multiply, and we get x is equal to 10 tangent of 36 degrees. Okay, which I'm going to put down a few decimal places here. It's 7.265. So our side marked with s would be equal to 2 times 7.265, which is about, let's just say 14.53. Okay, we have to find the perimeter. Remember, the perimeter of our pentagon can be found by taking 5 times the length of one of those sides. So we're going to say the perimeter is equal to 5 times that 14.53. So the perimeter is approximately 72.7 centimeters. Now, there are lots of ways of doing this problem. This is just one way of going about it. Your teacher may show you different methods for doing the problem.